Pluto. Once considered the ninth planet in our solar system, now classified as a dwarf planet, it remains one of the most fascinating worlds ever discovered. Despite its small size and distant orbit, Pluto has captured the imagination of scientists, astronomers, and the public alike. Its story is not just about astronomy, but about how we define what a planet really is, how human curiosity pushes boundaries, and how discoveries can change our understanding of the universe. Today, we're going deep into Pluto's mysteries, history, and scientific significance. Pluto was discovered in 1930 by Clyde Tombaugh at the Lowell Observatory in Flagstaff, Arizona. The discovery was the culmination of a search for a mysterious planet X, thought to explain irregularities in the orbits of Uranus and Neptune. Although later calculations proved those irregularities were an observational error, Tombaugh's persistence revealed Pluto, a world so faint and distant that it required meticulous photographic comparisons to detect. Tombaugh was just 24 years old when he spotted it, and Pluto became a symbol of human curiosity stretching into the unknown. Pluto was named by an 11-year-old girl from England, Venetia Burney. She suggested the name after the Roman god of the underworld. The name resonated with astronomers for two reasons. First, Pluto was a fitting symbol for a cold, dark, distant world. Second, its first two letters, P and L, also honored Percival Lowell, the astronomer who initiated the search for Planet X. Within a few months, the name Pluto was accepted worldwide. For decades, Pluto held its place as the ninth planet of the solar system. But things changed as astronomers discovered more distant objects in the Kuiper belt, a region beyond Neptune filled with icy bodies and dwarf planets. In 2005, Eris, an object even larger than Pluto, was discovered. This sparked a heated debate. Should Eris also be considered a planet, or should Pluto be reclassified? In 2006, the International Astronomical Union introduced a new definition of a planet. A planet must orbit the Sun, be spherical due to its own gravity, and clear its orbital neighborhood of debris. Pluto fit the first two criteria, but not the third. As a result, Pluto was reclassified as a dwarf planet, igniting passionate debates that continue to this day. But Pluto's reclassification doesn't make it less fascinating. In fact, Pluto has turned out to be one of the most surprising worlds ever studied. The New Horizons mission, launched by NASA in 2006, gave us our first close-up images of Pluto when it flew by in July 2015. What it revealed shocked scientists. Instead of a dead, frozen rock, Pluto was a dynamic world with mountains of ice, vast nitrogen plains, and even evidence of geological activity. One of the most striking features was Sputnik Planitia, a giant, heart-shaped plain of nitrogen ice. This region seems to be constantly reshaping itself, with convection cells churning the ice in a process similar to boiling water. This means Pluto is not geologically dead, but active, even billions of miles from the Sun. Pluto's mountains are made not of rock, but of water, ice so strong at such cold temperatures that it behaves like rock. Some of these mountains rise as high as the Rockies on Earth. There are also vast valleys, frozen lakes, and even hints of cryovolcanism, where volcanoes could erupt with slurries of water, ammonia, or methane instead of molten rock. These features suggest that Pluto may have a subsurface ocean beneath its icy crust, kept liquid by internal heat and the presence of antifreeze chemicals like ammonia. If true, Pluto could even harbor environments where life might exist, albeit in microbial or exotic forms. Pluto's atmosphere is equally strange. Though thin, it contains nitrogen, methane, and carbon monoxide. This atmosphere is in constant flux because of Pluto's highly elliptical orbit. At times, when Pluto comes closer to the Sun, its surface ices sublimate into gas, creating a temporary atmosphere. As it moves farther away, the atmosphere can literally freeze and fall back onto the surface. During the New Horizons flyby, scientists observed layers of haze in the atmosphere, stretching more than 200 kilometers above the surface. These hazes scatter sunlight, giving Pluto a soft bluish glow. Another fascinating fact about Pluto is its relationship with its largest moon, Charon. Charon is so big, about half the size of Pluto itself, that the two bodies actually orbit a common center of mass, located outside of Pluto. This makes Pluto and Charon a double dwarf planet system, unlike anything else in our solar system. Charon has deep canyons, mountains, and a mysterious reddish cap near its north pole, likely created by gases escaping Pluto's atmosphere and collecting on Charon's surface. The gravitational relationship between the two worlds is also unique. Pluto and Charon are tidally locked, meaning the same side of Charon always faces Pluto, and the same side of Pluto always faces Charon. Pluto has 4 smaller moons as well: Nix, Hydra, Kerberos, and Styx. These tiny moons are irregularly shaped, tumble chaotically, and orbit in resonance with Charon. Their discovery revealed just how complex and dynamic the Pluto system really is. Beyond its physical features, Pluto has immense cultural significance. For decades, it symbolized the limits of human exploration. School children learned about Pluto as the 9th planet, and its demotion in 2006 sparked outrage and sadness around the world. Many people still argue Pluto should be reinstated as a planet, and campaigns to replanet Pluto continue to this day. The debate highlights how science is not just about facts, but about how we classify and interpret discoveries. In terms of numbers, Pluto orbits the Sun at an average distance of about 3.7 billion miles, or nearly 40 astronomical units. 1 year on Pluto, the time it takes to complete a single orbit, lasts 248 Earth years. Its day is about 6.5 Earth days long. Temperatures on Pluto are extreme, averaging around -375 degrees Fahrenheit. Its diameter is about 1,473 miles, making it smaller than Earth's moon. Yet despite its small size, it has a surprisingly complex geology and atmosphere. One of the deepest facts about Pluto involves its place in the Kuiper belt. The Kuiper belt is a vast reservoir of icy bodies left over from the formation of the solar system. Studying Pluto helps scientists understand the early solar system and the processes that shape the planets. Pluto is like a time capsule, preserving clues about the primordial materials that built the worlds we know today. There is also the possibility that Pluto's subsurface ocean, if it exists, could have survived for billions of years. This raises profound questions about the possibility of life in unexpected places. Traditionally, scientists thought life could only exist in the so-called habitable zone, where liquid water can exist on the surface. But discoveries on Pluto, Europa, and Enceladus suggest that life could thrive in underground oceans, even in the outer solar system. This expands our view of where life might exist, not just in our solar system, but in exoplanetary systems across the galaxy. The story of Pluto is also about human exploration. The New Horizons mission traveled more than 3 billion miles to reach it, a journey that took 9.5 years. At its closest approach, New Horizons flew just 7,800 miles above Pluto's surface, capturing data that continues to be studied today. The images and measurements revealed a world far more complex than anyone expected. They also inspired a new generation of scientists and space enthusiasts. After its Pluto flyby, New Horizons continued into the Kuiper belt, flying past another object called Eris in 2019. This showed that missions to distant, icy worlds can succeed and provide groundbreaking science. Looking forward, scientists hope to return to Pluto one day with an orbiter mission. An orbiter could map Pluto in detail, study its atmosphere over time, and even look for signs of a subsurface ocean. Such a mission would require advanced propulsion and power systems, but the scientific payoff could be enormous. In the grand scheme of things, Pluto reminds us that size doesn't determine significance. Even though it is small, it challenges our definitions, reshapes our theories, and deepens our wonder. Pluto is not just a rock at the edge of the solar system. It is a dynamic, evolving world, with mysteries still waiting to be solved. Whether we call it a planet or a dwarf planet, Pluto continues to inspire curiosity, debate, and discovery. So the next time you look up at the night sky, remember that far beyond the visible planets, beyond the gas giants, lies a tiny world with icy mountains, nitrogen plains, and a beating geological heart. A world that defies expectations. A world that proves the universe is always more surprising than we imagine. Pluto may not officially be the 9th planet anymore, but in many ways, it remains one of the most captivating,